Participation will be highly appreciated. All right. All right. So we have this expression. We have to express it as a partial fraction, meaning we have to break this expression down into smaller fractions. Colleagues, is this a proper or an improper fraction? Anybody to give this a try? Is this a proper or an improper fraction? Because that is step one first. Step one, whether it's a proper or an improper fraction. That's the first step you need to do. So proper or improper, this is a proper fraction. Why? For those who would ask, why are you saying that? Yeah, correct. Why are we saying it's a proper fraction? Yes, the power of x in the denominator is greater than the power of x in the numerator. Right? For those who don't believe, just expand this expression here. Multiply these two. All right, you're going to have an x to the power 3. That's the one we're talking about. The leading x, the exponent for the leading x term. Okay. Yeah, so this is a proper fraction. If it was an improper fraction, you need to do long division of polynomials. All right, so we've got two denominators, so it means we are going to break this down into two fractions. Here we're going to put 2x plus 1 plus x squared plus 4. So colleagues, can anyone tell me what we have to put on the numerator for this one, 2x plus 1? Here, since here we've got 2x to the power 1. What should our numerator be? Anybody? Mhm. On this side, yes, since this is to the x to the power 2, so our numerator, yes, bx plus c. Now I'm agreeing, I'm saying bx plus c here. Quadratic factor. Yes, whenever you say x to the power 2, just know it's a quadratic. All right, it's a quadratic equation, factor, function. Yes. If it's x to the power 3, cubic equation, cubic function, cubic factor. Yes. All right. So the next step now, we have to get rid of the denominators so that at least we can remain with these terms in the numerator, and it can be easier for us to get our values of a and b. So colleagues, what expression are we going to multiply by every term on both sides? Mhm. 2x plus 1, x squared plus 4. Even this side, 2x plus 1, x squared plus 4. All right, so on the left hand side, this gets cancelled out, this gets cancelled out, we remain with x squared. All right, on the left hand side, this fraction multiplied by this expression here. All right, we can see 2x plus 1, 2x plus 1 there. So we get rid of this 2x plus 1 here and this 2x plus 1. So we remain with a times x squared plus 4. So I'm going to write here a open brackets times x squared plus 4. Then on this side here, plus b, we're going to multiply this fraction by this expression. We can see that we've got a common factor, x squared plus 4, x squared plus 4. They go. So remain with bx plus c 2x plus 1. All right. Any questions up to this point? Okay. Now, colleagues, here it's going to be kind of hard to separate A or B or C from the others, because if you try to look for any X values, you won't be able to separate them. Okay. You won't be able to separate. So the only method we're remaining with is the equating the coefficients method. So what we have to, the first thing we have to do is we have to expand these expressions. So we're going to say a times x squared. What is a times x squared? What is a times x squared? And then let's multiply a times 4. Yes, class. A times x squared. No one knows a times x squared. Yes. Colleagues, these are the dying moments. So we have to participate so that you make sure that you're on board. A times 4. Next, we have to also expand this expression here. All right. You have to expand the expression. So you're going to say bx times 2x. What do we get? You're going to get 2bx squared. Are we all comfortable with that? You get 2bx squared. There any questions? Let me know. Bx times 1, bx. C times 2x. Plus 2c and x plus c times 1, c. Wonderful. Now on the left hand side, this x squared, we have to express it as a four quadratic equation because here we are equating coefficients. All right, so you're going to say this becomes x squared plus 0x plus 0. Right, remember the format of a quadratic equation. It's ax squared plus bx plus c. So this a here, this b, and this c, a, b are the coefficients, c is a constant. Coefficient is just a number before a variable. All right. So the first thing that we're going to need to do first is we need to arrange this expression. All right. The x squared, we bring them together. The x's, we bring them together. Then the constants, they stay by themselves. So we're going to write it like this. It becomes now a x squared plus 2b x squared plus bx plus 2cx plus this 4a comes aside, 4a plus c. Then we're going to need to do a bit of factorization. All right. So we need to factorize first this expression here, ax squared plus 2bx. What is our common factor here? Between ax squared plus 2bx squared, what's the common factor? Yes. Ax squared divided by x squared, what did you remain with? Ax squared divided by x squared. A. 2bx squared divided by x squared. 2b. Plus, we now come to this bx plus 2cx. Common factor, x. Bx divided by x, b. Plus 2cx divided by x, 2c. Plus our constants here, 4a plus c. So this is the part where now we're going to do the equating of the coefficients. All right. Equating of the coefficients. So if you look at your left hand side, x squared, the coefficient of x squared is 1. So you write 1 here. On your right hand side, the coefficient of x squared is a plus 2b. Are we okay with this, colleagues? Any questions? Next, we look at the coefficient of x. We come to the left-hand side, the coefficient of x is 0. On the right-hand side, the coefficient of x, b plus 2c. When we come to the constants, the numbers without variables, on the left-hand side, our constant is 0 here. Now, right-hand side, this 4a and this c, since they did not have any x, so they're regarded as constants. So you write 4a plus c. Any questions? All right, so here you're going to ask yourself, okay, so now how will I be able to get the values of a, b, and c? Well, if we use simultaneous equations, first we list our equations. Say equation 1, 1 equals a plus 2b. Equation 2, 0 equals b plus 2c. Equation 3 equals 0 equals 4a plus c. So now simultaneous equations, you're usually dealing with two equations. All right. So here we have to manipulate one equation such that we can substitute it into another equation so that we remain with two equations. We need to substitute one equation into another equation so that we remain with two equations. So let me illustrate what I mean. All right. Let's take this equation here, 0 equals b plus 2c. Let's adjust it, all right? Let's make b the subject of the formula, all right? So we're going to say b0 equals b plus 2c, all right? So we make b the subject of the formula, meaning we take this 2c over to this side, all right? So it will be b equals 0 minus 2c. Then you're going to say, therefore, b equals negative 2c. So we've adjusted one equation, and we're going to put this new adjusted equation into this equation 1 so that we can solve equation 1 and equation 3 as simultaneous equations. So before I go further, any questions? So at this point, it's up to you, whichever equation you feel comfortable with. If we wanted, we would have used equation 3, would have just said c equals negative 4a, right? Then substitute it into equation 1. We would have used equation 1, adjust it, all right, and substituted it into equation 3. But in this question, first we've adjusted equation 2, okay? B equals negative 2c, and this we're going to, as I said, we're going to plug it into equation 1. So equation 1 is now going to look like this. 1 equals A plus 2, then the B, we're going to substitute it with negative 2c. So equation 1 now becomes 1 equals A, 2 times negative 2, that's negative 4. So A minus 4c. That is equation 1 now, after we've adjusted it. And I said we're going to work with equation 1 and 3. Equation 3 is here. 0 equals 4a plus c. So now we can solve these as simultaneous equations. Colleagues, I believe we still remember how to do simultaneous equations. I believe we remember how to do simultaneous equations. Can we try to find the values here? You can use substitution method or elimination method. Which one should we use? Elimination or substitution? Elimination or substitution method? Which one? I'm supposed to go for dinner, so we need to move at an average pace. Yes? Substitution method? Okay, if we use the substitution method, we can use equation 3, right? We can say let's make C the subject of the formula. All right. So if we make C the subject of the formula, it becomes C equals negative 4a. Okay. We've just adjusted equation 3. C equals negative 4a. So since we're using the substitution method, we're going to substitute this into equation 1. So equation 1 becomes 1 equals a minus 4c. Now the c, we're going to substitute it with negative 4a. Negative 4 times negative 4a, that's positive 16a. A plus 16a, 17a. To get the value of a, what do? We divide both sides by 17. Divided by 17, divided by 17. Not negative 17, positive 17. I don't know why I brought this negative sign. Yes. Therefore, a equals 1 over 17. So we substitute this into this adjusted equation we made. C equals negative 4a. So we're going to say C equals negative 4 multiplied by 1 over 17. which gives us negative 4 over 17. Then we substitute this one to our original one, which we had here, b equals negative 2c. Back to this one there. So b equals negative 2c. So c we substitute it with negative 4 over 17. Negative 2 times negative 4, that's positive 8. So b equals 8 over 17. Are we okay with this? Excuse me. So since we found the values of a, b, and c, we go back to our original equation here. Right, this one here. Okay, let me write it again here because it's going to need some adjustments too. So we had x squared over 2x plus 1, then x squared plus 4. So we said here we had 2x plus 1. All right. We had a on top here. So a is equal to 1 over 17. So we're going to put here 1 over 17 plus here we had x squared plus 4. Then you had bx. All right. So b is 8 over 17. Okay, 8x over 17. Bx plus c was what? Is negative 4 over 17. So negative 4 over 17. All right. So we simplify this. All right. So usually whenever you have a situation like this lower denominator just comes here. All right. That is just the shortcut. All right. This will come here. So you're going to have 1 over 17, open brackets, 2x plus 1 plus, all right, here if we solve this fraction it becomes 8x minus 4 over 17, right? If you solve this fraction here it will become 8x minus 4 over 17. All right, and as I said again, this will come here, so it will be 8x minus 4 over 17 x squared plus 4. So this should be your answer.